Since we left off our configuration video having created a SQL database, we'll start our backend development by creating a db.js file, which will be responsible for handling all the database reads and writes. Of course, we'll do this using the Sequelize ORM, so we'll begin by initializing a new Sequelize object and then defining the model that corresponds to the quotes table that we created in our configuration. The only CRUD operations our quotes table really needs are create and read, so I'll define two functions, add quote and get quotes. You'll notice in my add quote function I did something a little bit hacky, which is I used a random number generator to create my IDs. Truthfully, I'm a little bit new to Sequelize and couldn't easily figure out exactly how to auto-increment IDs, so I went by with a hack for now, but obviously would not do this for production. With our db.js file written, let's go ahead and add an index.js file to our bot folder and call the add quote and get quotes functions from our db.js file to verify that they work. It looks like it executed without error, and we can run a quick select directly from our database to make sure that the data was written. The next thing we're going to do is actually build our bot, and our bot's going to use this price endpoint from the IEX OpenAPI in order to get the most recent stock price for any ticker symbol that a user inquires about. The bot is going to perform three critical functions. The first is that it's going to listen to the Relay REST gateway for any incoming messages from users. When it receives a message, it's going to take the ticker symbol from that message and make a request to the price endpoint of the IEX API. And finally, it's going to send an outgoing message through the Relay REST gateway back to the user with the quoted stock price. Of course, it's also going to write a record to the database upon performing these actions. We're going to use the socket.io-client module to establish a connection to the incoming messages endpoint of the Relay REST gateway. You'll notice that we check to see if there's some nested body data in the message JSON blob. And this is because Forsta can send several types of messages, including control messages such as a read mark. So we only want the bot to process the message if it's the actual text message sent by a user. The remainder of the bot code is pretty straightforward. However, I'm also going to export a getQuotes function from the bot in order to abstract the db.js code from the higher level files in the Node application. The next thing we'll do is add our main.js file to the application, which you may recall is the file that will be run when we run npm start. This file will define all of the server-side endpoints that our client application can interface with. We'll begin by simply instantiating our Express application and simply returning an index.html file to any GET requests made to the server. We'll save defining our API endpoints until we know that our server is running properly. Finally, we'll add our server's API endpoints to service our client application. The most complicated part of the stockbot is authenticating with Atlas. The first step is to authenticate the stockbot's username and password with Atlas. However, that may not be the only step. Recall that every client device owns their own private key. Atlas has no access to users' private keys. The implication is that anytime any user authenticates with Atlas from a new device, the device must also be registered to that user. Registration entails the new device generating its own private key. The private key it generates is chained to the existing private keys. Atlas does not possess any of those private keys, therefore the new device must contact an existing registered device to generate its private key. If no registered devices can be contacted, the only option is to re-register the account. This voids all existing private keys associated with the user, breaking the chain and causing previously registered devices to re-register and get a new private key seeded from the device that re-registered the account.